So if we go up, go to the next effect, we see the socioeconomic status. Again here, the sums of square of 5,900, degrees of freedom 2, so 5,924 divided by 2 is 2,962 for the mean square. Now we put this in ratio to the error, 287. So 2,962 divided by 287 is 10.308 for the F value. Now again, we want to know what's the probability of getting such an F value, and if there is actually no difference, right? If the null hypothesis would be true, and you see the probability is very small. It's not exactly 0, as we discussed in class. It's probably 0.000 something, and we're just cutting that off at 3 digits. So if it's very likely that there is actually a difference in gender, so that therefore we reject the null. We reject the null hypothesis. We go with the alternative hypothesis. We assume there will be a difference in gender. And then for the next, the next main effect, for the SES, it was it. The next one is the gender. The gender is 980 divided by 1 is 980, and I would put this mean square of the gender in relation to the error mean square. So 980 divided by 287 is 3.41. And now we test the significance of this F value. Degrees of freedom is 1, degrees of freedom 2 is 161. And for this F value, we get a significance of 0.067. So we see we're getting closer to the 0.05, but still, because we are larger than 0.05, we retain the null. We go with the null, we assume that there is no difference between the genders. Now, here you see then an overview of the estimated marginal means. That would be means that are corrected for various sample sizes. So up here you have the means, how they actually are. That's really the way they are with these group sizes. The estimated marginal mean smoothes things out and assumes that all the group sizes are the same and corrects the means for those imbalances. So that's why these values are a little bit different than what you see up here in descriptive statistics. So then to the plots. The plots are really good to look at, and you actually can look at those right after you look at your descriptives if you want, because they give you a good overview of what's going on. And usually I ask for them twice. So I ask once with girls and gender on the x-axis and socioeconomic status as the grouping. And then I ask again with socioeconomic status on the x-axis and gender as the grouping. It gives you, it's the same, so the same data points, but this gives you a different look on things. So here you can see, okay, what's the highest status? Which status is the highest? And it happens to be the high status above all the others, and this seems to be a pretty clear distance here. Then between low status and medium status, we see, okay, there seem to be similar. However, there's a little bit of a drop off here in low status for the boys. Okay. Second thing that we see here is that the boys over here seem to be always lower than the girls, right? The girls are here, the boys are here, they're a little bit lower. The girls are here, the boys are here, the boys are a little bit lower. The girls are up here for the low status, the girls are here, the boys are down here. So you see here a pretty big difference in the lowest status between the gender. So a little gender difference in high status, it starts to be a little bit bigger in the medium status, and in the low status it starts to be really big. Then for the next table we have, you see the gender as they as they're matched up with the socioeconomic status of the girls from low status to medium status, and then in high status it really increases. Similar pattern for the boys. However, they start lower. They're in low status, they're low. Then the medium status, they catch up a little bit, and then in the high status, there's hardly any difference between those two. But here what we see nicely is that from the low to medium to high, there's a big trend upwards as you increase in status. So this here already gives us an indicator that there might be a main effect for socioeconomic status. And actually also here, if you see the same trend in all groups, you could think that there would be a main effect for gender. But since we do then statistical testing, we found that, remember it got close to 0.05, it's 0.067, but it was not quite significant. Now, in a note for the interactions, sometimes when you see interactions usually show up when you have lines that are crossing each other or that are fanning out, like this here, but even more extreme if they're really fanning out. Sometimes that can be an indicator of an interaction, or if they cross over. So for example, if all of a sudden boys would be higher than girls, that could be an indicator for an interaction. That it depends, the gender effect depends on the status. But again, not always when you have a crossing of the lines is it a significant interaction. It just you get a visual indicator that there might be an interaction. Then you still have to test it with statistics. So this was the output of the 2 way ANOVA in SPSS.